being 10:02, and since these rooms I think opened 5 minutes before, I'm going to go ahead and get started with this. If everyone should be able to see now the screen share. If you haven't got it, go ahead and put something in the chat. I'll try and keep an eye on that while I am presenting. So good morning. I am sure a lot of you have heard about continuous integration and continuous development, continuous deployment, continuous delivery, or whatever the D happens to stand for this week. And there's all sorts of instructions about this, which usually start with something like, well, you can create your new project and put it in a Docker container, and then you use Jenkins to just move the whole container up to the cloud, which is great when you're starting a new project. But when you're working at a company, a lot of times you don't have that luxury. So this is going to be the story about how my company started and has been continuing on that journey. My name's Lorien Rensing. I am a software developer at Making Everlasting Memories. I have been there for about 8 years now, and in that time, we've had a lot of changes in how we've built and deployed our software. So let's take a look first at where we get started. And that, of course, is with the monolith, which is big and it is scary. And honestly, the code was probably just as bad. So we had multiple solutions, which looks like a good idea. Each solution was for a different area of the business. There was a single sign-on project that handled our access control. Everything was set up in IIS, so anything that needed to be under single sign-on lived under that in IIS. And if you didn't have to have access control, it could have its own site in IIS. And then we had some separate solutions for things like Windows services and a data broker that just sort of run in the background. And they looked something like this, but they all shared some common low-level projects. And these projects controlled our models, our enums, a lot of ASPX controls, because these projects were generally created when web forms were the thing to do. We had custom exceptions, we had common utilities, all of our data access, and all of our business logic. So it's all shared between all these projects were shared between all of our solutions. So that led to some issues. We had common code, and then every now and then we'd have to add some new code, which had to be tested. And then you updated all the solutions back with that common code. So that meant a couple of things. First, anytime you changed this common code, you then had to deploy not only the solution you needed the change for, but every solution that was referencing that common code. And because of that, and all of the testing that was involved, that meant that it was a lot more likely that people, instead of just updating the old code, would add new code instead. This led to duplication, and more to the point, this common code kept getting bigger. Then we had the database. When it was originally designed, the thought was to make it highly extensible so that we could use it for future business opportunities. We had it in textbook third normal form, which sounds great up until you consider that the textbook in question for our database was probably something the size of the unabridged Oxford English Dictionary. I've seen this in hard copy, It's about 6 feet long. Not inches, 6 feet. We also had SSIS packages for moving some of our commonly made changes between environments, although these did have to be kicked off manually, and that led to some problems of its own. For starters, we had large amounts of data in this database, and we needed to keep that up to date for business continuity. We had a lot of tables involved, and because these tables were highly normalized, it would obscure how the data was used and make it really difficult to work with from a business standpoint. For instance, it would take 4 tables to store the data about one image, and that didn't include any type tables we were using. And like I said, those SSIS packages had to be kicked off manually. We didn't have a way to automate them and just say, okay, when I push this code, automatically run these packages as well. We were using Team Foundation Server as our source control and our build server, which had the advantage of it worked very nicely with Visual Studio. And since we're a C# shop, that worked pretty darn well. And it would let us deploy code to our dev, test, and production environments. But of course, it had issues too. There really wasn't any sense of branching, just merging. Check out the code, merge it back in, and hope you don't get merge conflicts, which also meant that it was pretty easy to accidentally overwrite someone else's code if you'd been working in the same file. And if the feature you'd been working on wasn't completely finished, there was a chance that it might be deployed to production, even though it wasn't ready. This goes back to those common projects, because even if your solution might not be something that was ready to be deployed, someone else changes some common code, and all of a sudden, oh, you need to do something to make sure your code doesn't break production. It also had multiple ways that we could deploy code to any given server. We could use the Visual Studio Publish tools, and then we had some command line scripts that we'd run in PowerShell. But there was no really good way to tell what code was currently on what environment or when it had last been pushed, which also meant that our QA team was never quite sure what code was ready to test and where they should be looking at it. And we had a nice manual deployment process. Every 2 weeks, early in the morning, usually on Tuesday, we had PowerShell scripts that would archive the previous versions of the code, build the new versions. We were in Amazon Web Services cloud servers basically since the time I started here, so we were able to use their machine instances, and so these PowerShell scripts would copy the built code up to a new version of our what we called Prod Web Gold, basically the Amazon machine instance that we would spin up our servers from. We'd have to manually update the database either with the SSIS scripts or with custom scripts that people had written. Then we would increase our number of web services, which are our web servers, to bring our new code online. Then we decrease our number of web servers to our standard amount, which would take the oldest servers offline. And then we could begin our manual smoke testing. And we would have to really hope that we didn't have any issues found during that smoke testing. Otherwise, we'd have to run more scripts to start building the archived versions of the code and make them the gold copy and spin it up and spin the servers down, and really hope we didn't have to roll back any of the database changes we'd made either. And even outside of that early morning smoke testing to get ready for production wasn't the easiest thing either. Everything was being done manually. Nothing was automated. We didn't have any real source of truth for what code was live on what environments, or for what code was ready to be tested, because sometimes you get partially complete code. For example, you might have the new buttons on the front end live, but they weren't doing anything. So QA would see the button, go to test it, and try to put in a bug saying, hey, this button doesn't work. And then they get back, but that's not a bug. I haven't finished writing the back end yet. So to make sure that QA could test everything, we would have to have a code freeze to make sure that everything really was ready to be tested and there wasn't anything sneaking in to screw that testing up. So that leaves developers with, well, okay, well, what am I going to do now until they're finished testing this? And then our problems with partially completed code not being merged meant none of that code could be tested until the whole thing was finished. So bugs that might have been able to be fixed earlier got found a lot later than they could have been. And then there's those shared projects again. Every time those changed, we had to regression test everything manually. So we needed a new plan. And this is where we started looking at continuous integration and continuous delivery. So just as a refresher for those of you who aren't using it yet or who are really curious about what the D actually stands for in CI/CD, with continuous integration, you have a repository where all of your code lives. The developer will check out their code, develop it on their local machine, open a pull request. It goes to a build server that will build the code. At minimum, this makes sure that your code will compile and you won't have completely broken code before you merge. You can also add other restrictions. For instance, we have a requirement on our build server that any unit tests have to pass. After everything passes, that code can be merged back into the repository. And there's now a new batch of working code that the next developer can use, or the same developer, to check out the code and continue local development. So that takes us to continuous delivery. We have our continuous integration cycle, which means we've always got code that will build and meets the minimum standards. So if it gets deployed, it won't immediately break. Then we have our main build server, which builds the code for production. And yes, it looks like we have two build servers here, but one of the reasons for this is sometimes we need to change some configurations between environments, mostly involving things like site URL names. So we go to a build server and we now have a build of our code that's ready to go to production. And so when we decide that it's a good time to go to production, we can then release it. So this lets you choose when you're building your production version of the code and when you're releasing it. So that's continuous delivery, the idea being that at any time you can make the decision to build the code and to deliver the code to your customer. Continuous deployment is one step beyond that. Once again, you have your continuous integration, so you have code that is always buildable in your main repository. The difference is that once everything is committed back to the repository, in continuous deployment, the code will then automatically go to your build server, and when it builds there, it will be automatically deployed to the web server with no manual intervention needed, which on one hand is excellent for getting code delivered very quickly, but not so great if you have people who want to look at that code before it goes into production. Of course, we weren't doing all of that from the beginning. So we started working with a couple of new tools, specifically TeamCity Build Server and GitHub. So just for a bit of comparison between our old projects, these were using ASPX web forms. We used nHibernate as our primary means of data access. We were making direct calls, often from the code behind of those web forms, to our services. All of our testing was manually. So since we were in need of an uplift to the front end anyway, we started writing entirely new projects. These were written as single-page applications. We moved to using Entity Framework rather than nHibernate for our data access. We started using dependency injection to decouple some of our code, and we started adding automated unit tests. We started using GitHub for our source control, which gave us a lot of advantages. Each developer could have their own branch, or sometimes multiple branches if that was what was necessary. We required a pull request to merge code into the main branch, which meant that everybody knew what was going in, and you weren't going to just force your code to overwrite someone else's code. Before you could merge, we set a restriction that a different developer had to require the code to merge. A different developer had to review your code before it could merge. And we hooked it into our build server to require that the code built before you could merge it. And for that, we were using TeamCity for our continuous integration. This meant that we could set up rules such as unit testing becoming a standard part of our development process, and the unit tests had to pass for the build to succeed. We also did some work on those standard low-level projects. To do that, we turned those into NuGet Packages. So instead of having a tightly coupled bundle of projects, each one became its own NuGet package. Then any of the solutions that needed to use any one of these projects could bring them in as a package, but only the ones they needed, and they only had to update it when code that was related to them changed. Code related to them had changed. So all of these NuGet packages were built on our TeamCity build server, and then we set up a private NuGet package feed so that we could pull them in as packages. So that meant that when one of the packages changed, you didn't have to regression test all of the solutions. You only had to test the solution that was using the updated version of the package. So that brought us a lot of improvements. With the TeamCity build server, we could see what code had been deployed and when it had been deployed. Having unit tests gave us more confidence in our code quality. We were able to automate a lot of our build and deployment jobs instead of having to write and update PowerShell scripts. We also did some work around our database and started adding descriptive schemas instead of having everything in a schema called core, which, while true, wasn't necessarily useful. So that brought us into a spot where we could start using continuous delivery, and that gave us a lot more flexibility in our deployment schedule. If we had stuff ready in 1 week, we could do that. If it took us 3 weeks to get something ready, we could do that too. Of course, there were still some issues in this puzzle. We still had the old web forms projects. They didn't have any unit tests, so they had to be tested manually. And we still had to balance long-term and short-term projects. Long-term projects, we still had that risk of code gets merged in and then goes live before it's ready, but we might have short-term projects or bug fixes that needed to go up a lot quicker. Our main branch could hold one or the other, but if it held both, we were back to our original problems of risking incomplete code going live. There was also some confusion about our test environment. What code was supposed to be living there? Anything that had been written and was ready and that the testers might want to look at? Or was it only the code that we were planning on releasing to production? So QA was still confused about what was really ready to test. And even with those new schemas that we've got, the database was still very large and still very normalized. So we needed to move on further and make some more changes. One of the biggest things we did was give QA control over our test environment. We wrote new build scripts so that QA could execute them and move code at a specific point in time to the test environment. Now, this required some pretty strict naming conventions of the branches, but they were also very straightforward. It was simply test and then a branch number, and the branch number was the year plus an incremented release value. We also created a dedicated Slack channel for discussion of our production releases. And if you're familiar with Slack, you can set a topic, and that topic would always get updated when we had a new branch on test. So everybody knew, okay, this is the branch that's currently on our test environment. QA also started automating a whole lot of our regression tests. So that meant instead of having to take a long time going through every solution that got deployed to production, they could kick off the automated test and only have to manually smoke test code that had changed. They were also able to start running these regression tests in our dev and test environments, which meant that if things changed during the development process that might cause these tests to break, we could find out about it early, which meant we could get it fixed early. And we were even able to move some of these regression tests onto our build server, depending on exactly which tool we were using. In general, the stuff they wrote in Selenium gets kicked off manually on some dedicated testing machines, but we also have tests written in Nightwatch that are run automatically by our build server. So that means that a lot of the regression testing can now take place as part of the build process, since we can require those tests to pass just like we require our unit tests to pass. We also started doing continuous deployment to our dev environment. So that means that that dev environment always has the latest code that somebody has checked into our main repository. And because we are using continuous integration, we know that code is going to build. So that meant that the developers can very quickly verify their code works on an actual server and not just their local machine. This is really useful if you're doing things that involve, say, email that have to be tested on a server. And QA can take a quick look at code that's not yet in the queue for release, but that they might want to get an idea of what's going to happen. We also started adding toggles to our code. Every time we created a new feature, we wrapped it in a toggle. And we created an internal tool that let us easily control that toggle state. So that means it's now safe for incomplete code to go up to production, because all you have to do is turn the toggle off, and an if block will route the behavior to the old working code and ignore the new code. We also started breaking up our one large database into many smaller databases. Each time we created a new project for a feature, it would get its own database. And that database would only contain data relevant to that particular business need. And with that, the databases were not quite so normalized. We started focusing on the business-driven logic rather than letting the data drive the business. So we had a lot of improvements to our deployment process with this as well. We started versioning our ProdWeb Gold AMI, which meant that we could now push our ready for deployment code to the AMI in advance of our deployment time, but we could leave the older version as the selected gold copy until we were actually ready to deploy. So all this pre-work in building the new AMI can get done whenever it's convenient for our DevOps people, rather than forcing everyone onto a strict schedule. This means when we're ready to actually deploy the code to production, it generally takes less than 15 minutes. And this is just a matter of switching what our selected gold copy is, moving it to the new version, spin up the new servers, spin down the old server, and it's ready. So this means that code can be released in the middle of the day, and we no longer have to come in at dark 30 to release code. And having the toggles means that even though code might be on production, the feature release can happen at any time after that. A lot of times it does still happen when the finished code is pushed, but sometimes we have to coordinate with outside partners. And then we'll sync up turning on our toggles with when they release their code. There's still issues with this, of course, but it's getting better. Code that's on the test branch is kind of hard to do bug fixes on because of that strict naming convention, and because we do lock it down fairly tightly to make sure it's not changing while it's being tested. All of our toggles have to be manually added to and removed from the database, which means basically that the old toggles mostly just sort of sit around cluttering things up. And we don't have a standard process for removing the code once a feature is deemed good and live in production. So stuff just sort of gets removed as people are updating future things. And of course, there's the database. Our original one is still very large. And because of all the new databases, sometimes some of this data does get duplicated. And admittedly, a lot of this thing is things like type tables and such, but it is, like I said, duplicated. And we still don't really have any automation other than those SSIS packages as far as moving data between environments. The SSIS packages get kicked off automatically, or don't get kicked off automatically. Some of the stuff still has to get moved by custom scripts. So how did we go about making the change? Well, the first thing we needed was to have a goal. And despite the topic of this presentation, our goal wasn't actually CI/CD. CI/CD was a technique we were using to reach other goals. First, we wanted to release high-quality software. And our software quality wasn't bad, but we knew it could be better. We wanted to be able to deploy our code more often and continually be showing value to our customers. And we wanted it to be easier to deploy our code. The manual process was very cumbersome. We had to come in early in the morning. It was just sort of a generally frustrating thing. We took advantage of outside consultants. We knew there were better ways to do this, but our job wasn't really to keep up with tooling. Our job was to keep up with what our customer needed. So we brought in outside consultants. They were able to advise on what tools were available and which ones might work for our system. They were able to help us get the initial setup taken care of. And they were able to advise us on some of the best practices for using these tools. We set up a lot of standards around this. We started making sure we were doing things the same way every time and documenting what that same way was. We created a wiki so that everyone would know what these standards were. And we kept reviewing it to see, well, can we automate this part of it? Then we can let the computer make sure it will happen the same thing, will happen the same way every time, which computers are very good at doing. We also started making incremental code changes. They're easier to test. They let you release value faster. And we discovered they usually have fewer bugs. Starting in 2017, we started tracking how often we were pushing code and how many bugs we found in each code push. So the solid blue line shows how long it was between any given push, and the dotted orange line is the number of bugs found in each push. And one of the things we discovered when we started looking at this graph was how closely the number of bugs found tracked with the number of days between pushes. The most days we took between pushes in 2017 was 56, and we found 20 bugs that push. The most bugs we found was actually 24, and it had been 32 days since our previous push. So obviously we wanted to improve on that. So in 2018, we went from 28 pushes to 47 pushes. So for this one, the most time, we still have that same tracking between how long it's been since we released code and how many bugs we found. So on our longest gap, we had 44 days between pushes, and we found 18 bugs that day. So we started trying to shorten things up. We also started learning from our mistakes. One of the early ones when we moved to Team City was not locking down our main branch. One developer realized that if you push directly to master, you don't need a pull request. And he overwrote several other people's code in the process. So we started locking down our branches, and that's when we started requiring the pull requests and started requiring review by a separate developer and requiring the code to build. We also learned from some of our testing mistakes. Originally, when QA took over deploying the code to the test environment, they would start by testing the newest code, and then they would change the toggles into the production state and test the oldest code. But what that meant is that code that was ready to release might not get tested. So we changed the order of things. So QA would start testing our oldest code first, then turn the toggles on to reveal the newer code, and could start testing that. And since it wasn't necessarily immediately ready for release, if the newest code didn't get completely tested before our next code push, that was still all right because those toggles would be turned off on production. We also started reviewing what we were doing, and we found the agile retrospective process worked really well for this. We would discuss the lessons we'd learned and the changes that we wanted to make, as well as, how had the last batch of changes worked, and did we want to continue with those, or did we want to do something else? And it's very important to have everyone involved in this, not just the developers or even the developers and testers, but also DevOps, basically anyone who's involved in this deployment process. And you have to be willing to change your processes, but not too many at once, because then you're not sure if the change you got is the result of one process or the combination of processes, and the same goes for if it was a failure. So where are we now? We've got a standard process for how code will be developed, which is basically the top line of this diagram. And that is basically our continuous integration process. Then at some point, QA will decide to take a branch out of that. And that will go on to our test environment. They'll first test code that's going to immediately be released to production, and then start testing the long-term production. And then we've got a standardized deployment process. So this means that now our process for making changes, moving them across environments is both documented and standardized. We've moved to a twice-weekly deployment schedule, and in 2019, we had a goal of 100 deployments. We actually had 104. Our 100th deployment was the beginning of December that year. Sorry about that. And on deployment 100, we had a big celebration. We're on pace to actually outdo that this year. We're keeping to our Tuesday and Thursday mid-morning schedule. And every time the code on production is called good, we'll update our test branch with a new batch of code. And that's what the testers will then begin testing. We stopped tracking things in October of 2019, but at that point we'd had 90 code pushes. The most days between pushes was 20, when we found 12 bugs. Most of the time we had a much shorter time between deployment, and that orange line you see is now really flat. We are finding a lot fewer bugs. We started toggling everything, not just new features, but sometimes even bug fixes will get toggled. If it's a major enhancement to an existing feature, it gets toggled. There's some minor bug fixes and enhancements that might not get toggled, and this is generally if it's going to take less than a week from starting to write the code until the code being completely finished with testing, that might not get toggled, but otherwise it's toggled, so we don't have it in production until it's really ready. So where are we going from here? If you could tell from this picture, it looks like the future. We've still got database challenges. That's our big remaining monolith. There's a lot of cool stuff you can do with containers, but a lot of those involve having a database that's part of that container. And the scale of ours makes that impractical. And it's not under source control. We've got backups, of course. We've got a couple of them, which is useful because data consistency is important, and the other thing is data availability is important. And we still don't have a really good way of communicating when changes need to be made. We've tried some things with Kanban boards and sending direct emails or things like that, but since that's not automated, it involves somebody remembering to put the message out there and somebody remembering to check for a message. We'd also like to move to continuous deployment in other environments, but there's that whole database thing. How do we sync these changes automatically? The dev environment's not such a problem because our local development machines are set up to talk to the dev database. So those initial changes usually get made at the same time the code is written. But we don't have yet a way to automatically sync these changes. And if we're doing continuous deployment, are we going to need to use toggles even for the smallest of bug fixes? Since we don't want to release a code that would fix one bug and create two more. And how do we handle it if there is a rollback required for some reason? And we still don't have a good answer for that. Currently, our rollback strategy is to simply change the version of our gold machine instance, spin up new servers, spin down old ones, and the code's rolled back, less than 15 minutes, same as a regular deployment. But if everything's going automatically, how do you get back to that old version? The last thing we want to do is we want to start using microservices. We've got a lot of common behaviors that are used in different parts of our system. For example, uploading images or videos. And each solution has its own copy of the code to do that. If we could hook into a microservice that was only loosely coupled and did just one thing, then it would be both easier to test just that one thing and deploy it by itself without having to deploy the entire solution. So at this point, I will go ahead and open the floor up for questions. So, and I see I've got one from Edwin in the chat. So, it sounds like the testing is happening after the sprint. and whether we're looking at testing during the sprint along with development. So one of the things I didn't really cover in here is that we're not using the strict Scrum model of fixed length sprints anymore. We were using that for a couple of years, and we found it didn't give us as much flexibility as we needed. It definitely gave us a lot more flexibility than the previous waterfall model, but it didn't account for things like absences, especially unplanned absences or holidays. And it came back to that old issue of the code freeze of how do we make sure that QA is able to test the code before it gets pushed. So yes, testing is happening after it's all been written, but after in this case sort of means 2 or 3 days as opposed to 2 weeks. So in that sense, testing is sort of happening during the sprint. The other thing I sort of glossed over is one of our requirements. Before opening about 90% of our pull requests, the developers are required to have QA do a desk check with them. So that allows the developer to prove that their code really does work as opposed to just compiling. And it gives QA an idea of what is there to be tested. So I'm not sure if that answers your question, Edwin, or if you've got anything else you'd like me to clarify on that. And was there anything else anyone wanted to bring up, either questions or comments to discuss, since we do still have a couple of minutes before this session is scheduled to end? And I just did a quick check on, for anyone who's curious, as of today, or possibly right now, we're on our we're scheduled to release our 70th code change of the year. So Austin's got a question about getting cross-team buy-in for this initiative. One of the things that helps is we're a very small company. We've only got about 30 people, and most of those are involved in what we call the delivery team, which is basically everyone in development, everyone in DevOps, everyone in QA, and everyone in what we call our creative team, which is graphic design and communications. So we had all discussed, either in our individual teams or in groups, wanting to improve software. We'd been working in an agile model for a while. And so that meant that we were all very much in favor of changes that would let us deploy better software faster. So that mostly meant we had to get cross-team buy-in from the business side of things. And that was basically how we sold it to them, is this will let us deliver more value to our customers faster. So really that was the whole way of selling this, is you do it with a customer-focused approach. It's like, yes, these are exciting buzzwords, but we're focused on what does the customer need? What's going to be best for them? It happens in this case that it was CI/CD, but it didn't have to be. If there was something else that would have been a better proposition for our customers, it would have gone that way. Does that answer your question, Austin? You're welcome. And I will give a few more minutes if anyone has any further questions, but it is 10:47, so if any of you want to go off to the networking before the next sessions begin. Thank you very much for being here at the talk. I hope you enjoyed it. It's really hard to tell without the feedback you get from being in person.